power of negative 0.16 t gallons per minute, where t is the number of minutes since the pump was turned on. If the tank contained 800 gallons of water when the pump was turned on, how much water to the nearest gallon is in the tank after 20 minutes?
Okay, so this will be our integral, but we have to put in the initial. The tank contained 800 gallons of water at the beginning, so let's write. That is our initial amount. So we're going to add the 800 and then find the integral by typing it all in on the calculator. So this one, like, you do no work by hand. Okay, what was the function for integral? Math what? 9. Math 9. So let's go to math 9, everybody. Hope you're typing with me. Oh, look at me, I forgot my 800 first. And then math 9, 0 to 20. He's not typing. And then we have our function given. We have 30, open your parentheses, type it exactly as you see. E to the negative 0.16 t. And then close out parentheses, and then we have dx. Okay, let's make sure I typed it in correctly. All right, where's yours? Go back. You're like, yes. Okay, did y'all get 1220? Yep. Should anybody miss this? No, please. Okay, number 82, Josh, let's read.
If f prime of x equals square root of x to the
Can you start over again, because I hear talking?
if f prime of x equals square root of x to the fourth plus 1 plus x to the third minus 3x, then f is the local maximum that x equals.
Okay, so I'm going to take my PVA card again. So they're giving us the f prime, so local max happens when we're going from positive to negative, correct? What number is guaranteed between positive and a negative? 0. So we're going to let one of them equal 0. So I'm going to let y1 equal to 0 and put that complex form into y2. Let's type it in together. So we have square root. Are we all typing? She's not typing. He's not. Okay. Plus 1 plus x cubed minus 3x. Let's double check. All right. Can we go to Zoom 6? Yeah, go to Zoom 6. That's fine. Quick thing, if your calculator messes up on you, you know y'all get like syntax error or whatever. Here's what you do. Okay, this is very important. You do, what was it? Second plus 70, okay. Second, the plus sign, number 7, the number 1 and 2. I don't want to do it because I already typed things in. When you do that, this is going to reset your calculator back to default, but you have to remember to put it on. The mode should automatically be in radian mode. Yeah. Sorry, I went off a little tangent. Okay, y'all good with that? Okay, this is only if it gives you a syntax error, some kind of error, and you're like, I don't know what happened to the calculator, it'll reset it. All right, at Zoom 6, let's see what the graph looks like, and I'm looking for positive to negative. Positive to negative. So would you agree we're going positive to negative right here? Okay, I'm going to go second count, 5, and hover pretty close to it. And when I press enter 3 times, what answer choice satisfies? You're typing it. I heard C. Very good. Okay, let's go on to 83. Okay, on number 83, Charlie, let's read.
The graph above gives the velocity v in feet per second of a car for 0 less than or equal to t less than or equal to 8, where t is the time and seconds of the following, which is the best estimate of the distance traveled by the car from t equals 0 until the car comes to a complete stop.
Let's underline best estimate. So let's kind of recall 4 different Riemann sums. We had left Riemann sum, right Riemann sum, trapezoidal Riemann sum, and midpoint, right? Which 2 were pretty close approximation if you recall from Unit 4? Trapezoid or the midpoint, okay? honestly, the midpoint is easier to work with. Let's try that first. So we're looking at it from, does it say exactly what subinterval? Nope. So I'm gonna go ahead and section this by every Tuesday. So I'm gonna go like this. So if I look at it from between 0 to 2, my midpoint is right here. It's exactly not 50. Someone give me a number that's pretty close to 50, but greater than 40. What number does that look like? 40, 47? So if I double 47, since 1 to 2 is 2 difference, how many would that give us? 47 will give us 94? Yeah? Let's find the next midpoint. That one's nice. It's 40. What is 40 times 2? 80. Y'all are scaring me. Okay, the next one. This midpoint right here is a little bit over 10. Are y'all okay if I just said about 15? All right, 15 times 2. 30. The next one is, I would say it's less than 5-ish. Can we consider 4 maybe? What's 4 times 2? 8. So let's add them all together. So we know 80 and 30 is going to give me 110. Oh, actually, we have a calculator, right? Why am I doing this? So we have 94, and these are all approximated. And if the number is pretty close to each other, we don't have to go on any further. I made a mistake. That's not 80, but 8. 212. Do I see a number pretty close to 212?
Yes.
Yes. So which one will be most likely? Okay. For questions like this, they're not going to give you two numbers that's going to be like 212 or 210 and 215. That would be really mean. It'll be Jurassic. Y'all good on that? Again, isn't this doable?
Yes.
Although some of you guys could not multiply by 2. All right. Let's go to 84. Okay, Livy, 84. Let's read that one.
For negative 1.5 less than x equals 1.5, let f be a function with first derivative given by f times x equals e to the power of x to the power of 4 minus 2x to the power of 2 or squared plus 1 minus 2, which of the following are all individuals on which graph of f is computed.
Okay, let's underline concave down. Concave down happens when f double prime is what? Negative. Because we're using the calculator, let's let that do all the work. So here I go. So we're going to look for when, right here, concave down. Let's do this. Let's put y1 is equal to 0. On y2, since I already have the first derivative, if I derive that, isn't that the second derivative? And something cool it's going to happen on the calculator that you guys might like. I'm going to use the math 8 function and literally type this in on the calculator. Because f1 is already given to us. And if you say x equals x, as long as you're graphing, it's going to give you the x value when they're crossing each other. Okay? So let's try that out together. y1 we already have. y2, we're all typing this in by saying math 8. And we're typing in the given f prime. If your neighbor's not talking, tell them, do it. Not talking, typing, tell them to do it. Say, hey, type. Minus 2x squared. And then we have plus 1. So let's see, we have, that's good. Good. And I'm going to put x on there. It's going to calculate whatever value we're intersecting. And let's go to, it was already at Zoom 6. All right. So concave down happens when my value is negative or positive? Negative. So I'm going to figure out what is this value, that value, and that value. So second calc 5. I'm going to go over here, enter 3 times. So everything below that is negative. That means since they gave us our bound, our negative happens at negative 1.5 to that number. If I were to round that number, that would be up to what? Negative 1. And we need a union because we have another negative. Second calc 5 again. Now I'm looking at this value here. We're finding the negative value right here, or 0 value. And that value is at, okay, let's talk about this number. I'm glad this came up. Do y'all see it says to the power of negative 13? So it's saying I'm moving my decimal 13 times, so it's infinitely small. So one number is getting very, very small, basically to nothing. 0. And that is gonna happen. Just make sure it says negative and some big power. Second calc 5, and let's go to the right side. And that number is gonna give me 1. And that's, which answer choice is gonna satisfy in the basket? D it is. Okay, what's up?
Did you not plug the first derivative into y1?
Yeah, you can. And then also on this one, I wanna look at this visually, because I think visually it might be helpful to a lot of you guys. So the graph basically looked something like this. Y'all draw this with me. Draw this with me. So we're looking at when it's below, and that's what we were basically finding out right there. Okay, so if you like the visual, here it is. You already also had it on the calculator. We good? Okay, let's work on the last one, 85. Okay, Frank, when you're ready, let's read number 85.
The graph of f prime, the derivative of f is shown in figure above. Function f is the local maximum at x equals.
So f prime is given, and we're looking for local maximum. So we're looking for when f prime is doing what to the sign? From positive to negative. So we have negative to positive, positive to negative. Automatically, what answer?
1.
Done.